Hello, my dear students. How are you all? I am fine. I am Khandakar Fazle Rabbi, lecturer, Department of Chemistry, Milestone College, Uttora. Dear students, during this pandemic situation, welcome you all to our online chemistry class. Today, we discuss about some important topics from chemistry's second paper, chapter 3, quantitative chemistry. My dear students, our first topic is redox titration involving iodine, and here we discuss about iodimetry and iodometry. What is iodimetry titration? My dear students, the process of determination of amount of any reducing agent by the redox titration with standard iodine solution is called iodimetry. In this process, standard iodine solution is taken in the burette. The strength of different reducing agents like thiosulfate, sulfite, arsenite, etc. may be determined by this process. Dear students, now the process of iodometry titration. The process of determination of an oxidizing agent by titration of iodine liberated in the reaction of that oxidizing agent with an iodide salt with standard sodium thiosulfate solution is known as iodometry. In this process, generally the amount of oxidizing agent like copper 2 plus ion, dichromate ion or permanganate ion is determined. For example, to determine copper 2 plus ion, it is allowed to react with potassium iodide when equivalent amount of iodine is liberated. Then the amount of liberated ion is determined by titration with standard sodium thiosulfate solution. Here the following reactions take place. Generally, equivalent amount of oxidizing agent equivalent to equivalent mole of iodine, and this is equivalent mole of reducing agent. My dear students, according to iodometric titration, now we solve a mathematical problem. Here given 1.3 gram impure copper, and this impure copper dissolved in 50 ml dilute sulfuric acid, and here in container B potassium iodide solution is present. In container C 100 ml 0.2 molar sodium thiosulfate solution is present. Now our question is, use the solutions of the STAM and calculate the percent impurity of impure copper. My dear students, in the STAM, if copper is added to this dilute sulfuric acid, then it produces copper sulfate. That means copper plus sulfuric acid. Here we get copper sulfate plus sulfur dioxide plus 2H2O, and the reaction of copper sulfate with potassium iodide solution, here we write copper sulfate plus potassium iodide Here 2 copper sulfate reacts with 4 potassium iodide and we get Cu2I2 plus iodine plus 2K2SO4. Dear students, in this reaction we see that by the reaction of potassium iodide with copper sulfate, it produces 1 mole iodine. That means 1 mole iodine is liberated from this reaction, and this liberated iodine reacts with standard sodium thiosulfate solution. 2 mole standard sodium thiosulfate solution reacts with 1 mole iodine and it produces Na2S4O6 plus 2NaI. That means we see that 1 mole iodine reacts with 2 mole sodium thiosulfate, and according to these two reaction, my dear students, according to these two reaction, we see that 2 mole copper to copper sulfate equivalent to 2 mole copper sulfate equivalent to 1 mole iodine, and this 1 mole iodine is equivalent to 2 mole sodium thiosulfate. That means 2 mole sodium thiosulfate. So my dear students, we can write 1 mole sodium thiosulfate equivalent to 1 mole copper sulfate, and we can also write 1 mole sodium thiosulfate equivalent to 1 mole copper 2 plus ion, because in copper sulfate ion is a spectator ion, so we write here 1 mole copper 2 plus ion. My dear students, here we can see that 1 mole sodium thiosulfate equivalent to 1 mole copper 2 plus ion. So we can write 1000 ml 1 molar sodium thiosulfate solution equivalent 63.54 gram copper 2 plus ion. Here we write 1000 ml 1 molar sodium thiosulfate was here given here present 1 mole sodium thiosulfate solution, and sodium thiosulfate here 1 mole sodium thiosulfate is present, and we know that for molar solution or for 1 molar solution 1000 ml 1 molar solution contains 1 mole solute, and that's why we write here 1000 ml 1 molar sodium thiosulfate solution. And again we can say that 1 mole copper 2 plus equivalent to 63.54 gram, because the molecular mass of copper 2 plus is 63.54 gram. And now our given sodium thiosulfate solution is 100 ml, and that's why we write here 100 ml, 100 ml, and concentration of given sodium thiosulfate solution is 0.2 molar. Sodium thiosulfate Na2H2O3 equivalent to 63.5 into 100 into 0.2 divided by 1000 gram copper 2 plus, and here we get the answer is 1.2708 gram copper 2 plus. So my dear students, this is the amount of pure copper in the given impure copper. So we can write impure copper equal to 1.3 minus 1.2708 gram, and the answer is 0.0292 gram. 0.0292 gram. So the percentage of impurity equal to 0.2 0.0292 divided by 1.3 into 100%, and the percentage of impurity is 2.25%. 2.25%. So percentage of impurity in impure copper is 2.25%. My dear students, now we discuss about what is Beer-Lambert law. When UV light is passed through compounds having a multiple bonded and lone pair of electrons, such as carbon-carbon double bond or carbon-oxygen double bond, scattered, transmitted part of incident light is absorbed. A part is scattered, transmitted. As a result of absorption, the intensity of light passing through material bodies, that is, the intensity of transmitted light decreases. The fraction of incident light absorbed depends on the thickness of the absorbing medium. Scientists Beer and Lambert derived a quantitative relationship between the decrease in intensity of light due to passage through a homogeneous medium and concentration of the solution. This is known as Beer-Lambert law. So the Beer-Lambert law, which states the intensity of transmitted light decreases exponentially to the thickness and concentration of the solution through which light is passed. Mathematically, this is like log I naught by I equal to epsilon CL. Here I naught equal to intensity of incident light, I equal to intensity of transmitted light, L equal to length of solution path, C concentration of solution, epsilon equal to molar extinction coefficient. Here log I naught by I equal to A, this is absorbance. So we can write A equal to epsilon Cl, that means concentration C equal to A by epsilon L. Now what is HPLC? High performance liquid chromatography, in brief, HPLC, formally referred to as high pressure liquid chromatography, is basically a liquid chromatographic separation process in analytical chemistry used to separate the components in a mixture, to identify each component and to quantify each compound. Now what is GC? GC, that means gas chromatography, is a common type of chromatography used in analytical chemistry for separating and analyzing compounds that can be vaporized with decomposition. In preparative chromatography, GC can be used to prepare pure compounds from a mixture. It can be used to identify a substance, or it can be used to know the exact concentration of a sample, that is, quantitative estimation of a sample.